Hello everyone, welcome to the GSOC 2022 demo day of the Liquid Galaxy project. After my words, students will be presenting you their work, and also we will have a demonstration in both his usually virtual machines or in Liquid Galaxy Lab different rigs, Liquid Galaxies that we have for real, with many different screens and with real computers. Also here I would like to thank our colleague Pau, because he's been testing with the machines at the JEDA's Liquid Galaxy Lab all the students' projects next to me and other students, and I want to say hello to him for his great job helping both the students with the bugs and so on. And of course I have to mention all the different mentors that we have this year working with us on the Liquid Galaxy project. And especially would like to thank our powerful girls, Claudia, Carini, Claudia from JEDA, Carini from Brazil, Paula that is now in Madrid, Emily from Vancouver, Canada, and then our many mentors including Lot, Victor, Otavio. Lot is in Spain, Victor in Barcelona, Otavio is in Brazil, Gabri I think is in Barcelona, Merul is in India, Pau from JEDA also, Victor is in Cupertino, California, Moises in Madrid or Barcelona, Mario in La Rioja, Ivan in JEDA, Mark somewhere between Brazil and Barcelona, and me that I'm located usually in JEDA. Thank you mentors for your great job and helping the students and contributors to achieve their goals. There is one thing I'm very happy as administrator of the project next to my colleague Claudia, that this year we have an objective. I think it's very good. It was something like to be having all the applications to my right here, all the applications that will be developed for this year's GSOC, having an Android application being the master of the core of the application. I mean, having all the data, all the logic, all the code inside an Android application. Also, several students use other technologies like Flutter. Here is Flutter also, and Kotlin. So I'm very happy because this is something very interesting for the Liquid Galaxy project in general, because we will have more visibility, having the applications already before just GSOC ended this year. We have all the applications published on the Play Store, and this is nothing. It's not simple, because we have to push all the students to have their work in advance, and also then we have to make the different activities, different actions with the Play Store, Google Play Store, to push the applications and also to get those published for real. You know, sometimes you have complaints from Google regarding different questions about privacy or whatever. So I'm very happy, and also here I would like to thank at least two persons initially, Alejandro and Victor, who helped a lot on this stuff of publishing the apps on the Play Store, this year apps, and also Alejandro's project that was for refurbish all the applications that we have but never were published on the Play Store, and then he refurbished the code and make different changes on the APIs and so on. And then finally we have, last year we have 3 applications published on our Play Store, and this year I think we are going to 13 or 14. That's a lot, and this is super for we have been done all together, of course next to the contributors that have developed their project, but also it's a work team, and we are very happy, I would say, all the community. Think about that. This also will give visibility to the students, because having the applications in the Play Store will be easier for them to say, hey, I have developed that project and this is already, you can download it directly on your tablet or your phone maybe from the Play Store, and this is fantastic. Also we have published or try to publish the applications on other Play Stores like the Huawei's App Gallery, and I think again this is very interesting for the project, because our experience, we started to do that kind of activities maybe 4 or 5 years ago, our experience is that if we publish, if we do the project with the code on an Android application, it will last more years. I mean, usually when students develop, contributors develop their applications using many different of applications, like whatever kind of database, whatever kind of Node.js, backend, PHP, I mean, whatever, Python, whatever they use. The problem is that you have to maintain continuously those applications and also run them on a server. The way of doing the applications on an Android base has helped a lot for us, and I think it's a good idea. So thank you for listening my words, and let's start with the different students. See you again.
Hello everyone, my name is Pablo Sanchez Adrián. I'm a Spanish software engineering student specializing in machine learning, and today I'm going to show you the first chess in the world capable of playing against a satellite. The main idea of this project was to create a new way of playing chess. How does it sound, the idea of playing chess against a satellite? Well, that's what we did. You will be able to play against a strong AI located in a satellite, but you won't be alone. You will vote for a movement, and the most important movement will be the one that you all will play. We also provide an individual game mode, just a normal chess game between you and your local machine. We didn't stop there. We thought that we could use the Lucid Galaxy rig as a visualizer of the current chess game, but 2D doesn't fit our style. We want 3D, and I believe the results speak for themselves. At this point, let me thank Hyperspace for making this project possible, especially Eduardo and Felix. Also, thanks to Hybridium for their support. To build this project, we decided to divide it in 3 sub-projects. First, we need to be able to exchange data with the satellite. Second, we need to build the screen visualization. And third, we need the remote controller, which is the one that you will be using to play this game. We decided to start with the core of the project, which is satellite communications. The plan is to use SFTP just like a mailbox. So when the satellite needs to send us a package, it will leave it in the mailbox and we will get it from there. Same happens when we need to send the package. What's the mailbox then? The mailbox is a ground station capable of connecting directly with the satellite. And also, it is the SFTP server. Once the satellite is ready, it will leave the current chessboard status in the ground station, and our scheduled cloud function will fetch the package and update the database with its content. Also, when we need to send the package, there is another scheduled cloud function that will create and send the package to the ground station. We have used Node and JavaScript and deployed them to the Google Cloud Console. Then we have the visualization project, where we use mostly web technologies. WebSockets for the communication between the screens, server, and controller, and Three.js for the 3D visualization. The server is developed using Node.js with the help of Express.js and modules like Socket.io. Lastly, we have the web controller that allows us to play against the satellite or local play, view the satellite's current location, view top chess plays, and connect to the Lucid Galaxy rig. We have used Next.js, which is a React-based framework, and to connect to the screen, we use WebSockets, and the entire project uses JavaScript. To sum up, communicating all these different subprojects allowed me to learn how to create complex M2M environments, including cloud computing, HTTPS certificates, and old-school SFTP servers. Once you open the app, you will see all the sponsors and then the login page. As soon as you log in, you will visualize the main screen where there is the navigation bar with some essential info such as the name of the project, your name, connection status, and navigation buttons. You can also turn on the dark mode. Let me show you the About page, where you can see the logo of the project, author, tester, and mentors, as well as the sponsor and a brief description. If wanted, you can easily get the location of the satellite by using the Find Sat button located in the navigation bar. You can move throughout the map freely by hitting the top right blue button that says Untrack. To track it again, hit the same button. Now let's connect to the rig. To do so, click on the LG setting button located in the header, and you will see a pop-up window where you can enter the master machine IP. Once you enter it, you can save it by clicking the Save button or save it and connect by using the green button that says Connect. If you have already entered an IP, you can hit Connect directly without entering any. Once you hit Connect, instantly the current chessboard status will be displayed on the screens. The default game mode is satellite mode, so if it's your turn, you will be able to vote for a movement. If you change your mind, you can rectify, but be careful, you only have 3 items. If you hit the mode button, you will see a game mode selector, where you can choose between satellite and local play, so let's change it. As soon as you do that, it will appear below the chessboard a difficulty selector, easy, medium or hard. When one of you makes a move, it would be highlighted. Also, if one of you is in check, the king square will turn red. Above the chessboard, you will see which turn is it at the moment. You can reset the game by using the red button that says Reset. Lastly, we have the top place, where you can reproduce some master players' chess games. As soon as you hit the button, you can select any of the 10. By doing so, below the chessboard will appear a controller so you can stop it, go forward, backward, check the speed of the game, or end the play. If you decide to end the game, the current chess status of the play will disappear and the game mode will change to the satellite mode. Left of the chessboard, you will find all the view controls. You can set white view or blacks, rotate the chess in any direction, or change the inclination angle of the board. You can set the default position by hitting the centering button. The green joystick moves the camera horizontally and the blue one will change the depth of the camera. Lastly, above the blue joystick, you will find 2 buttons named Chess and Earth. Click on the Earth button to display an illustration of how this game works, so you get a better idea. By pressing the chess button, you will go back to the chessboard view. If you want to check what the chess community has voted, you just need to press the Votes button. You will see it in your app, but also on the second screen of the cluster as a scrolling text. You can hide the logos, if needed, by clicking on the button that says Hide Show in the LG settings. You can see that there are 2 more options. As you can tell from their names, you can reboot and power off the rig. Do not worry if you misclick, because you will have to confirm your action. You will be able to play any of the game modes already playing, even if you don't have a rig to connect to. Let me show you by disconnecting right now. To conclude, this was my first year as a GSOC contributor, and all I can say is that this is an excellent experience, where I've been able to improve my professional skills in a challenging environment. Google Summer of Code also granted me the opportunity to connect with a worldwide community, where I met Andreu Ibanez from Lleida Liquid Galaxy and my mentor Victor Sanchez. I want to thank Andreu for his commitment and incredibly inspiring attention to detail, who helped us to improve the results. and Victor Sanchez, who has been giving me tips to improve the quality of my code and develop a much better working application. Thanks for this experience, and I hope you enjoy the first chess in the world capable of playing against a satellite.
My name is Alejandro Gianmarcos and I am a GSOC 2022 contributor. My project is Android Application Refurbishment. Liquid Galaxy organization has been participating in Google Summer of Code for 12 years, and during all these years, there have been many contributors who have developed applications to be used in a Liquid Galaxy. However, some of these applications haven't been released to the Play Store. My project consists of checking, fixing bugs, updating, and releasing those apps to Google Play Store. Now I will show you which apps I have to check. The first one is Image Satellite Visualizer. This app shows you images captured from satellites in a Liquid Galaxy device. Main problems with this app was caused by incompatibility between the Kotlin and Gradle version, also some dependencies and using ProWare to reduce memory space. We can see Image Satellite Visualizer on Play Store. Here, Liquid Galaxy Lab Space on Play Store, Image Satellite Visualizer. We can see the app here and Play Console here. Okay. The next one was Homeless Aid Panoramic Interactive System, or HAPIS. This app is a social project to connect homeless people, creating them a profile and people who want to help providing clothes, food, or anything else could help homeless people. The main problem I had with this app was API case, because it uses Firebase and Google Maps API, so I had to contact with developer and get new case for her app. I also changed Kotlin and Gradle version and upgrade some dependencies. The next one was RAS, or Reforestation Assistance Simulator. This app was created to help on reforestation of degraded areas alongside Dronicoria using drones to plant seeds. Main problem with this app was because of line vitals and privacy policies that were incorrect. It was a chaos to release this app because there was a line created on Play Console. Someone tried to release Rust with the main release, and they created an open test with version 2 of the app and an internal test with version 1. So two different versions, many problems. Each version with different permissions and some functions changed. So as you can see, I had to release the last version to the internal test, open test, and after that to the main release. That's because Google Play checked first internal test, second is closed test, and third is open test, and the last one to be checked is the main release. So if you have different versions on each section, your app probably were rejected. We can see Rust here on Play Store, as we can see. And now the next one. The next one was Orbit Satellite Visualizer. This app shows the orbit of satellites on a Liquid Galaxy device. I had problems with its code, so it was easily to release it. I upgrade the Kotlin and Gradle version just in case. I also had to change the package name on each file because you can use the default package name com.example.etc. This is an issue I also found on Image Satellite Visualizer and Arduino Controller app. That's because of Google Play developer policies. The last one was Arduino Controller app. This app consists of a complement for a physics controller to be used with a Liquid Galaxy. Some of the problems were related to this controller. There were functions that used deprecated plugins, incorrect dependencies, etc. I also had to upgrade the Kotlin and Gradle version. Furthermore, it was necessary to upgrade the Flutter version and change some methods. We can see Arduino controller on Play Store here, and we can see also Orbit Satellite Visualizer here. Generally, apps problems were related to deprecated plugins. Libraries needed, all Kotlin version, Gradle versions, Flutter versions, and Dart versions. Methods that had to be migrated to the Android embedding last version of Flutter. In fact, Flutter apps were the most complicated of them because of plugins and methods that needed to be migrated. Finally, I will show you my main tool, Google Play Console. Okay, this is the Google tool to release apps. Many of problems I had with Play Console were caused by privacy policies and Android permissions. You have to know what type of permissions your app has. If you use location of users, their files, their Bluetooth access, what kind of information your app takes from the users, etc. Google is very serious with this kind of things. For example, most of Liquid Galaxy apps need location permissions. Google is very serious with background permissions, and if the app don't need it, it's necessary to delete that permission. Well, a couple of years ago, you could use background permissions without any problem. Now, Google demands you a lot of information about your app if you use that permission. That's why I had to remove it from each app. Okay, that's all. I want to thank Google Summer of Code and Liquid Galaxy organization for this opportunity. Thank you very much, and bye.
Hello everyone, this is Gautam Verma here, and I'm very happy to say that this is my second year in Google Summer of Code with Liquid Galaxy organization, and I'm very thankful to mentor and you to giving my this next time opportunity with Liquid Galaxy organization. So for this summer, I have built a project named TinyGS Data Visualization Tool, which is dependent on TinyGS and Liquid Galaxy, and running with the help of TinyJS APIs, and sends the command to Liquid Galaxy and visualize the satellite data on Liquid Galaxy. So our applications have majorly three functions. First is ground station, satellite, and packets, and there are some supporting tabs also like help and about. And I have also built in a good documentations on how to build TinyGS, and also prepared a video for building a TinyGS station. And so for today we will going through a demo of my Liquid Galaxy and my application named TinyGS. So let's see how my application looks like. This is our uh, emulator, and in background you can see that we are running with the Liquid Galaxy master machine. So let's open the TinyJS tool in our emulator. First, the user will see the splash screen with beautiful logos, and then just afterward, we will be redirected to LG settings tab. And in this tab, we have the following parameters like your username, password, total Liquid Galaxy rigs, and the URL to connect Liquid Galaxy. And along with this, we have some features also like clean logos, clear camel, relaunch, reboot, and shutdown. And we also have this beautiful status shower which shows the current status of SSH between our application and Liquid Galaxy. So right now we are not connected with Liquid Galaxy, so it shows in red. And apart from this, we have the three major feature in our application. First one is ground station, second is satellite, and third is packets. So let's go to the ground station, and under this you can see that we have lots of ground station which is running with the TinyGS, and available on TinyGS server also. So these stations are auto-tuned, and somewhat like this station is listening to BZ LoRa 6 and the version of this application, and it also confirmed 5373 packets also. So we have a sort of information about this ground station also, and we can update this list with the help of this refresh button. So let's click on this refresh, which says that we are not connected with internet. So we first have to connect with internet. So yeah, we are connected with internet. Then again refresh it. So it might be a little bit hangy because we are running the parallel machine together. So yes, we are updated with the ground station, and let's visit another tab, stands for satellites. This tab contain information about the satellites uh, running with or receiving packets by TinyGS. TinyGS actually stand for Tiny Ground Station. So this all satellites sending packets to TinyGS ground station. And under this we have also lots of satellites. Let click off any of them. So this satellite is not working. So let's check out some other satellites. Somewhat click on this. Yes, for this kind of satellite we have some desired amount of data information about it, like dimensions, weight, who manufactured this satellites, and who are currently uh, operating the satellites, and some sort of packets or information about the satellites is also here. So the third feature is about the packets. Under this, you will see the last 24-hour packets that is received with with the help of this ground station is available. This ground station is available on this tab, and this tab also contain the connection status shower, and again the refresh button. So let's click on any one of them. After this, after clicking, you will see a brief info like this is running on LoRa 436.703 megahertz frequency, and theoretical coverage is about 5,147 kilometer, and a brief intro about it. So apart from this three major tab, we have two more tabs. One is help and another is about. So under the help tab we have the user manual for the user who was completely unfamiliar with the TinyJS community, and this manual contain all the information like how to use this application, what parameters we supposed to enter this in LG settings tab, and like more than enough information is available in this tab. And uh, and yes, I have also put in some user manuals for a user who wish to uh, establish a TinyJS at their at the end we will so at the end we will see this by following about step we are easily able to use this TinyJS tool. But apart from that, if user wants to build TinyJS station, he or she will find more info about this on this link. For last, we have the About tab, and under this tab, we have the banner of our application and some brief intro about the developing team, the mentors team, and the tester team at Liquid Galaxy Lab, which is Prao, my mentors Meryl Liman and Andrew Banes, and Mario Mentor, and me, this is Gautam Verma. So if you want to check out the more details about me, here is my LinkedIn available with the code work available at GitHub also. And this is the version release of this is actually stable release 1.0. And so let's visualize the satellites on Liquid Galaxy. So to do that, we first have to connect our application to Liquid Galaxy. So just enter the details and click on you are now connected with Liquid Galaxy. Firstly, we will visualize some packets. So let's go on packets, click on faucet, and just click on visualize. So firstly, it will show the orbit view of the satellite's location, and bubbles will appear on the rightmost screen. I'm running with the master machine, so I'm not able to see the bubbles. And on the left most machine we will see the logo of application. I will show you later in this demo and attach the demo video recorded at Liquid Galaxy Lida Lab. So let's visualize the ground station. Just click on send to ground station, and we will go to the station, and it will again perform an orbit around the station, like the perfect orbit I guess, and with this big letters. And again in this case the bubbles will appear on the rightmost screen, and brief intro about there also. So apart from this, I have also built underground TinyJS station at my ad by the name of Liquid Galaxy. So let's see and check it out how does actually it looks. I hope you liked my project and demonstration of my video at Liquid Galaxy Lida Lab. And I want to give a special thanks to my mentors and Liquid Galaxy community who helped me a lot in building this project. And I literally say that this project is next to impossible if I didn't get any help from the tester Pao and my mentors. He like they really helped me a lot in solving the issues. And special thanks to all the other contributors also who helped each other to resolve the problems regarding reboot, relaunch, and restart, especially Yash for creating SSS documentation. So I want to say that this summer is literally spent well, and I have learned a lot of things this summer. So thank you so much Google for organizing this amazing event, and Liquid Galaxy for participating in as an organization. Thank you so much.
Infinite power, infinite power, infinite power, infinite power, infinite power, infinite power. Infinite power.
Hello, my name is Letícia and I am from Brazil. Today I'm going to present the final results of the project that I have been collaborating during the last month. It has been called Galaxy Asteroids. Galaxy Asteroid consists of a single-player and multi-screen game that looks like the old Asteroid, with the Deep.io mechanics. Players will control their spaceships in a limited battlefield, the space, with their virtual joystick, using an application fighting in a third competition in order to achieve the highest score, being what most players like. The project was developed using two repositories, one using TypeScript language and use it as the server of the game, and the other in Flutter to be used as the controller of the game. Both repositories are full well documented, and it explains how to install the game and also how to play as a standalone version of it. Let's talk about the controller. The repository uses an old project from the last GSOC called LG Retro Gaming. The goal of this project was to be the main controller of the different games developed by GSOC students. The application was working for the latest game, so it have been included the launcher and the script that allow to launch the Asteroid project. However, we know how hard can be install projects that are not developed by ourselves. For this reason, and to avoid problem with the installation, it have been added a new feature that allows to install the project easily. This feature can be extrapolated to the other games, and in the near future this feature will be arrived soon. With that, the installation runs smoothly and it works without risk for the owners of the Liquid Galaxy that can suffer during the installation process of the project. Before that, settings configuration must be placed, so once it have been configured the essential information to connect with the Liquid Galaxy, it will perform an SSH connection to being the connection before controller and write. Once it is done, just click the installation button and an spinner indicator will appear into the process of installation happens. Depending of the internet connection, this can take a long because it has to be cloned the project in the machines and also install some dependencies in case that the project do not already have installed it. Once we finish the installation process, the game can be launched as it was before. Doing this will open different Chrome browsers to execute the game into the Liquid Galaxy. After a while, the game is open and the controller shows the spaceship's controller to start playing. It also planned that in the future we will add a game selector as more developers joins to participate into the project to start scaling it into deploy new features. Regarding the game, we have created a solid base that allows us to create different games like FFA, Survival, Duel, Maze, and others. The game itself counts with two big bases in titles which are the players and the enemies. The players has the health bar allowing them to revive multiple shots. As long as the user gets points trying to destroy the asteroid, the maximum health increases, and also if he is not touched, the life can be regenerated to still play the game. Regarding the enemies, we have created a factor method that allows us to create multiple kinds of them. In this version, I presented three kinds of asteroids, from smaller and bigger sizes. However, the game also increased the speed from the three forms and also the randomness of their appearance increase as much time the player stands of the game. In the future, it should be great to have a vision that allows us to manipulate this in order to create different levels of game. The system also uses local storage API in order to save the highest score of the players. allowing them to save data, amount sessions, and compete between users. Finally, I want to thank you all the help received for the mentors that helped me to complete the project successfully and learn different languages that I was not used before. I am so grateful for this opportunity and expect to continuously collaborate with the development of the game and maybe mentor new students to help them start on the open source community with the hand of the Liquid Galaxy organization. Thank you.
Hello all, my name is Yashraj and I am from Lucknow, India. I am an AR/VR enthusiast and I love to do work based on visualizations. Once I found out that Liquid Galaxy is making such visualizations onto the Google Earth with the help of colored KML display, I found it really intriguing and appealing to me, so I wanted to work with them. Among the projects, I love the La Palma volcano eruption tracking tool, and now since I have been building it, I'm really satisfied with the work in progress we have come so far. And in this final demo, I wanted to tell you the La Palma volcano eruption tracking tool basically describes the volcanic activity that happened in the fall of 2021 due to the Cumbre Vieja volcano. So the people got affected, they have to evacuate, there were closed roads and municipality under strict orders. There were roads, buildings destroyed and possibly damaged. All of that is being displayed with the help of the Voltrack or the La Palma Volcano Tracker app onto the Liquid Galaxy. So we are presenting up to 8 tracks and a custom builder that allows us to pick any 2 dates and the data of which we wish will be displayed. The language support is up to 10 languages, means we can change into any other language, and also the KML balloons or the data onto the Liquid Galaxy will show a language change once we change it. Apart from this, we also have a day-night theme that allows us to pick the basically the theme of our choice, if we want the reading white color or we want to go into a dark theme or the popular night mode. So yeah, this was all from my app. Now I'll be presenting all of this work and I'll be showing all of this in detail. Thank you. Now I have started the Voltrack app and we can see the beautiful animation it shows on the splash screen. There is also some information popping from the right side as we launch the app for the first time. Also, the Liquid Galaxy is up and running in the background. We can see some visualizations. But before that, we have to go to the connection manager and establish the connection. The first thing on establishing the connection is that the demo logos will automatically come to the leftmost LG rig, which is LG3 in our case. So we have established the connection. Another feature that I'll be showing you is the app tour. So once we go back, we hit the app tour button on the right bottom side and we basically take a small tour of the app on all the basic what the menu options are doing. We have the day and night theme mode and I'll be showing you the different menu options now. So we have the help tab, we have some basic information and what they are doing, and the about screen which tells about the app and some credits to all the images which I have taken. And now the custom builder, I'll be showing you in detail this one. So what it does, the LG task, we will be doing the lighter task because if we relaunch or reload when we have all the 3 LG, it will just automatically slow the laptop. So yeah, now I'm starting with the historic track. I have clicked on it and the KML balloon has just popped up on the right side. I'll be showing you that. Also, I have clicked on the visualize in LG button and it shows the historic track in a very beautiful way in the master, and also if we like zoom in, it will also show in the slaves which is sharing it. So the historic track has the title, the subtitle, and also it has a beautiful image. Below it also is also some information which is synonymous to the information in the description that we are seeing in the info of the Flutter app. So yeah, this is our app, and now I can orbit around it. I have clicked the orbit button and look how beautifully that icon is rotating while the orbiting is happening. So yeah, this is some powerful tools of the Flutter that allows us to have some transitions or the basic animations that we got to love. And yeah, so the orbiting is happening, and it will just orbit once around the whole the La Palma visualization of the historic track. Now I can clean it, and we will be seeing something some other screens. Also, I have saved it. The historic track is saved into a KML file that we can later use it or import it into some other projects. So yeah, after cleaning and saving or downloading the file, we can now see some other visualization, but this time I'm thinking we will see it in Chinese. So yeah, I have switched to Chinese, and now I have clicked the La Palma track tab, and the KML balloon has popped up in Chinese on the rightmost LG. I'll be showing you how it looks, and now I've clicked the visualize button, and you can see how beautifully the loader comes from right to left. There is also a retry LG button. We can see it in the info tab. I'll be showing you what it does later. So yeah, the information has come up very beautifully in all the three LGs. This is the information about the volcanic activity. We can see the real activity in an image on the La Palma balloon. So yeah, this is the information and how it happened, the occurrence of the Kumbh Reveja, the sad happening, the volcano eruption that occurred. And not so beautiful information, but beautifully displayed onto the rig through various colored KMLs. And now let's see the map tab. I was telling about we have an interaction that is similar to a navigator sort of thing. We do any sort of touch interaction onto the map screen, and it will reflect onto the Liquid Galaxy. So basically we are controlling this beautiful panoramic display with the help of our Google Maps onto the Flutter app. So we can do the twist, the angle, the bearing, and any sort of movements. Like I have just did a bearing movement and I tilted it back to say the horizontal view, and the same thing is reflected onto the Liquid Galaxy. So yeah, it is a really good, powerful tool, allowing us to have some access to like all of the Google Earth with the help of our maps. Now let's go to something else. We are going to the custom builder. I'll be just checking some dates, say 1st November to 14th December, and I'll save it. The information has pop up into the balloon onto the right side, and it is in English right now because we didn't change language. I'll be showing you other language also. We will be seeing it in Spanish and in German later. So I have just checked the info and I clicked on the visualize in LG. Let it take some time. The tremor info is large. Basically, there were 8,000 like the earthquakes that happened during the volcanic eruption. So yeah, so much of the tremor that was going on. Once I have clicked it, now it is showing visualize. It has shown a beautiful toast message, and now the visualization has started. Yeah, we have the roads, the lava flow that happened till that date, the main eruptive event that is in the triangular green color, the natural land and how it got affected. So yeah, now I have switched to Spanish and I'll be showing you the situation map. So I've clicked on the situation map and we can see it in Spanish on the right side or the rightmost LG, showing the map ID situation, or I should rather stick to English. And I've clicked on the visualize in LG button, and it has shown the information. It is just loading it up. Yeah, so we can see the maritime exclusion zone, the roads that were closed, and all the area that got affected. And I just hit the retry button or the retry LG. We can see the beautiful animation, like it appeared from bottom to up, the loading that occurred. And now let's move to this. We have moved to German, and I just edited the video and cut out the parts so we can see what is the most important parts of this. We have the balloon that has pop up in the rightmost LG, and we can see the basic information. We have clicked the visualize in LG button here also, and let it just load onto the Liquid Galaxy screen. So basically the way of doing it is we first set the dates, and in any user defined dates we can check the info that we want to visualize. So yeah, the information is getting visualized now and it has come up. There is no LG retry button here because we are only in our custom builder app. We are not switching into the info tab or something else that we need a retry button here. Now I can show you the data. We have a data tab here instead of the LG retry, which is allowing us to have some basic information about the La Palma activity, such as the information taken from the central EO browser. So let's click on it and see what it does. So yeah, the information has come up. We have also the Liquid Galaxy logo, the GSOC logo. If I come, let me use the map tab because I shouldn't be touching the LG to move it. I should have an interaction from our app, which is like really most best way to do it, or the space navigator if I had it. So yeah, those are the ways to control the Liquid Galaxy. And now the GSOC icon, the La Palma icon hidden by the app, and the Liquid Galaxy has come up. Through the central EO browser, we can see that the red color thing is just not like the fire. It is the lava that have flown over a very large surface or very large region of La Palma. So yeah, that was it. We have all the info tabs and all the information. Thank you.
Hi everyone, I'm Paula Vidal, and this year I've been a co-mentor slash listening mentor for these year's GSOC, and it has been an amazing experience getting to know all the rest of the mentors, the students, being able to help in different projects, and also learning about the projects that the students have developed over the course of these months has been awesome. They've done incredible work. I'm so proud of everyone, and it's just been amazing. There, you can really see all the progress in their projects and the creative ideas that they've brought to life. So yeah, I'm very happy. Been very happy to do this, and in the future, I'd like to, maybe be a part of it of GSOC as a student, and in the future, a mentor also. Who knows?
As you might remember, we started last year also to publish the applications on Huawei App Gallery because it's the second largest store in the world after Google Play, and we think it's important for us to be there also, and also for you as developers to have knowledge about this platform. So I sent you a few days ago an email saying that if you want, of course, it's a personal thing, you can also upload your application to the Huawei App Gallery. This is something we are doing by the community, by ourselves at this moment. But if you personally, not as community, personally want to upload your application to this, you can have the opportunity to participate in this contest. Let me explain a few minutes explaining what this is. The contest is called Apps Up. It's I will see it's something like 5th year they do that. It's a global contest with plenty of money. Basically, they give away $1 million in different awards, in different prizes. So it's a innovation contest for applications. So the goal of this is develop applications like you all are doing this year, because all of your projects have an app. It's an application. I mean a mobile application behind. So I think that as you have done a very nice work, maybe it's good for you to present it to this contest. Let me go through the slides. So here we have some information. This is about they developed this in 5 different regions in the world. So I'm not pretty sure at this moment which one of we are in different places in the world. I usually say that we are in 10 countries, but the contest runs in 5 different areas. So it depends on where do you live. You apply to a different place of inside the contest. But the goal is this one: is developing seamless, smart, innovative, and cross-device applications. So you have developed the applications on Liquid Galaxy. Those applications are very, very different. No, our platform is a very different one. But the point is that you can present it to the Apps Up contest. Let's go for the next slide. Inspiration to be innovative. What Huawei wants at the end is that two different things. One is expose to the developers their brand, and also that they have they have plenty of new APIs and SDKs ready for being integrated in different applications. So they have what is called the HMS, Huawei, their own SDKs and APIs, I will say. So you can upload, we'll see later, your application as is it now. We are uploading it already, but you can make a short change in upgrading it to some of their many different APIs they have. You can find it on their website because there are hundreds. So if you use one of their APIs inside your application, you can upload the application to the contest, and as I said, you can try to win one of the prizes. Today, Victor is not with us. Victor is the mentor that is helping us on uploading the applications to the App Gallery. He was a winner last year. I don't want to mention the number, but he won thousands of dollars in an award, and he has been traveling in Spain and Europe for free, and his name is always going in all places because Huawei want to make public the people that had achieved an award. So he's one of our mentors. Victor, and he won last year. I don't want to say the quantity, but lots of money. So they have last year more than 10,000 applications submitted, and plenty of different 3 billion global impressions. That's a lot. So plenty of publicity for the people that develop the applications. That's not for you as a, because you can. It will be easier for you to when you start your careers, because you will have. You can say, I've been selected by Google Summer of Code. At least Gutam can say, I've been 2 times selected to Google Summer of Code, and also if you present the app and you are enough lucky, or you have your application is enough attractive, maybe you can win. And this is also something very important to have on your curriculum vitae and your LinkedIn. You can develop whatever kind of application, but of course we are talking about the applications we develop on the Liquid Galaxy. Most of them are for showing visualizations on multiple screens. This is the schedule. We are in the middle of the thing till the October 9th, so still 1 month and a half ahead. You can register and submit your application. All of the information, as I said, is in the website. Then some experts will make a preliminary review, and then after this, the top 30 worldwide 30 applications will be selected, and then in December will be the awards. So this is the agenda they have, the why they do the selection. But the most important thing, I think, is going to be there, that you require to put in your application at least one of their SDKs, one of their APIs. So imagine you already have developed it using, I don't know, for example, Guillem's project, the Hughes TensorFlow. Then maybe he has to use another artificial intelligence model system that Huawei has, or some of you have used, plenty of you have used, for example, Maps. So you have to use, instead of the maps you have used. I remember Pablo at the beginning started to use OpenStreetMaps. Then we changed it to Google Maps. And then in this case, if you want to present the application, it will be nice if you integrate the petal maps, they call it. So it's a must to integrate one of these SDKs that have APIs. So they will select on this criteria, user experience. Again, it's very important to have a nice user experience. Originality, the applications have to be interesting, different, and also they have to have a social value. I don't want to make one of your applications in front of the others, but as I said from the beginning, Just application, for example, has a special value because it's an application that we developed, we created as mentors. We ideate to have these applications, and they're just as a developer coded. It's something social because we did that to remember that there is a place in the world that they are having plenty of pain because they were affected by a volcano, many eruptions for almost 3 months, and it's a very sad situation. And we don't have to get them go, but we have to remember continually and try to help them in many ways. So as I said, $1 million, not bad, in 5 regions. And for Europe, it's 200,000 euros. But as I said, some of you are in India, some of you are in Brazil, some of you are in US, some of you are in Canada, some of you are in Spain, of course. So we are in different regions. When you go to the site and you register, you will have all the information. They have some different sites of the contest for innovation in using their APIs, the best game, best application, all scenario coverage, social impact, Tech Woman Awards, a special award for applications developed by women, applications developed by students, and also honorable mention. Those are the prizes. So as you can see, there are several of them that are $15,000, and in total are $1 million in different prizes. What else? Also, you have the opportunity to have help from them in the use of their APIs, also promotion, and they want that you pioneer innovation and also to make a digital inclusion, meaning that your application is developed to be used by anybody and incorporating things for education, environmental health, and so on. $2,000 for Europe, but as I said, in the other countries also is the same. This slide is the important thing is that the submissions close on October 9th, so you have still plenty of time to first finish your GSOC, and then if you want to apply to this, okay? So just you take a look at you use your search engine, you look for apps app Huawei contest, and then you have all the information. And also I send you on the last days I send you an email with all the information, so it's up to you to present your applications to the contest.
Hello all, my name is Vinicius. I'm from Brazil. I have 24 years old, and currently I'm doing a bachelor in computer engineering. In the last years, I've been collaborating to the Liquid Galaxy organization, where I worked primarily as a full-stack developer. Today I will show my project that I've been developing in the last months for the Google Summer of Code 2022 program. My project name is the Beam Liquid Galaxy Visualizer. The idea behind is to show Beam 3D models and metadata into the Liquid Galaxy using the Unity Engine program. That's 2D, 3D, and game engine. Just to contextualize it, Beam are a system where we have basically in a single file the structural plant of what we're building, the 3D model visualization, and also the metadata. Now let's see the app, how it's work. So when we start the app, we can see some logos, and after we can see a tutorial of what we can do with the app. When we came into the home page, we see an error. This is because we are not connected with the Liquid Galaxy yet. So first we need to connect with. The app establishes a connection with the Liquid Galaxy using the SSH protocol. So when we come in the settings, LG connection, we can set our credentials. So I will set the IP, 7265166, and the password. Now that we are connected, we can see a badge saying that we are connected, and also we can see some models. When we enter in a model, we can see the details of, we can see the metadata, and when we type into a metadata, we can see more details about. Here on the top, we have a button to open the model into the Liquid Galaxy. So when we open it starts to open in the Galaxy, and it starts to open the controller too. Depending on the device, the controller can be slow to load, so I will speed up this part. Now that the controller loaded, we can see some details. So on the top, we can clean and open our logo. So when we tap on the clean, the logo disappears. When we tap on open, the logo is open. On the bottom, we have some buttons, transformation buttons. So when we type on the move, we see an gizmo, and we can move your model, and it's moving on the Galaxy. The other button allows us to rotate the model, so we can rotate our model. And the other one allows us to scale the model, so we can scale it. The last button allows us to reset the model, so if something goes wrong, we can reset. On the bottom we have the metadata button, so we can see all the metadata of this model, and when we tap it on the button, it shows the data into the right display. This model that we are seeing is a demo one, but the app allows us to upload our own models and our own metadatas. So let's close this model and get back to the home page. Here we have, on the home page, we have another tab with the uploaded demos. Model, I will set the name of the model, and I will select a model. I will get the kitchen one, I save, and we can see the model. Now that we uploaded the model, we can see the details of. We don't have any meta yet, so we can upload our own meta. I will select the kitchen meta, and here we can see all the data and the details about. When we open the Galaxy, the model opens. So now that the controller loads, we can see the model. So we can move it, we can scale, and we can rotate. So here you are, our kitchen. When we tap on the metadata, it shows on the right screen. Both models has metadata, but we can also upload a model without a metadata. So let's get back to the home page, and let's open the truck model. That's one that don't have the metadata. So let's open on the Galaxy. When a model does have a meta, we can see that the card is hidden, and then also in the tablet we don't have the card. So I think that's all. More informations about the app can be found on the About page. So here we can see the GitHub repository, the organization's website, the email contact. I would like to thanks to Andrew for giving me this opportunity. Also my mentors Karini and Mark for giving help in doubt, and also my friends and family for the support. So bye.
Hi everyone, my name is Karine Pistilli. I'm a computer engineer from Brazil. I've been a Google Summer of Code student for the Liquid Galaxy project in the years of 2020 and 2021. In this year of 2022, I was very happy to participate as a mentor and be able to work and help the contributors of this edition. For me, the experience of being a mentor was very interesting and fun. I loved working with my mentees, having long conversations about the projects, the possible approaches to solve all the bugs, and also about the improvements they could make on their work. In my opinion, the best part of the process is right now, at the end, when I see the growth of the students and the work they've done till now. So I want to say congratulations to the contributors and all the mentors for all their work. So, good job. See you!
Hey everyone, my name is Michel Garrabaus. I'm a computer engineering student here in Brazil, and today I'm going to show you my project for the Google Summer of Code 2022 program. So, my project aims to collect and show data from satellites and ground stations using the SetNox database through the SetNox API. So, first, if we look into the app, we can see two lists. The left one is the satellites and the right one is the ground stations. But before we handle this data, we may go to the settings page by hitting the cog button into the header and connect to our system. Once connected, we can see it appeared the logos already here in the left screen. And once connected, we have some options like going to the Liquid Galaxy tab and having some Liquid Galaxy tasks here, such as setting the slaves refresh, so every time we update the slaves KML, it will update the screen. We can reset it as well. We can clear the KML and the logos, relaunch, reboot, and power off the system. So, going back to the home page, we may see there are a lot of items here. Let's check first the satellites. So, we may look through all satellites available into the SetNox database. If we tap one, like the ISIS one here, we may see its data right here. Its full data, available data. We can see its transmitters as well, such as its status, its ID, its type, and we may see to the two line elements. So this is used for showing up the satellites into the Google Earth. So its location, its orbit, it's all around this. So we may see another one here. So let's see the Transit 5B5. And we have all of its data here. And its image as well. So going back, let's do the same to our ground station. So let's hit this first one. It's loading its data. It's getting from the API. Let's wait. And here we are. We have its owner. We have the creation date and more info. Let's back to the home page. Here in the top, we may see the data amount, so we can see the amount of satellites, the amount of transmitters, and the amount of stations. So, here in the top, we may see there are the search field to be filled up, and a round button that represents the filters. So, if we go to the search filter over here, and we type like ISS, the search, we may see that it filters by its name, and also by its alternate name, like this one is Nalcom, but has the alternate name of ISS. We can search it as well by the NORAD ID, so 255 over here, search, and we may see the ISS as well. So let's clear the search, and we go to the filters. We have a bunch of filters to apply, so we can apply by status. Let's check this. Hit the filter button, and here we are. We have all the re-entered satellites. So we may check this one, just to see it's decayed. Let's go back and clear the filters by hitting the clear button. The same happens to the ground stations, so we can search it by its name. So let's do like this. We have every ground station that has KO into its name. We may search by its ID as well, so 256 search, we have all of the ones that has 256 into the ID. We may see into the filters as well that has a few less filters than the satellites, but it still has filters like the status. So let's see the testing ground stations. And here we are. There are just two with the ID 256. Let's take this out, and here we are with all testing ground stations. Let's clear the filter by hitting the clear button, and there we go. So all of its data, this data that we can see over here, is stored locally, so it's stored into the app. If we want to update this data, we may hit the sync button. I'm not going to hit it because I already updated mine. So, and there is this little blue icon in the top right corner of the app, into the header. that represents the navigation to the About page. So let's hit this icon. And here we can see all of the data info, such as my name, the name of the project, its logo, some my mentor's name, the Liquid Galaxy Lab support, the organization contact info as well, the partner logos too, the project description, and its current version. Let's head back to the home page, and now we can start to look something into the Google Earth. So let's start to see something into our Liquid Galaxy. The first thing that we're gonna see into it is gonna be a ground station. It's more simple, so let's choose the Hackerspace GR1, maybe. Hit Viewing Galaxy. So just remembering that we have to have our connection set up. So let's wait, and here we go right to the ground station. So here we can see its place mark, its name, its status right here. On the right screen, the most right screen, we have a balloon with its info, right? So such as its owner, its coordinates, its altitude. And we can, if we hit the orbit button, we can see that it starts an orbit tour around the ground station. Let's stop the orbit, and we shall as well hide the balloon by hitting the balloon visibility switch. Let's hit it. Just wait a bit, and here we go, no balloon to show up. Let's clear the KML by hitting the clear button into the header. Alright, no ground station visible. And now let's see satellites. Maybe let's check out the ISS one. So here we go, it's a famous one. Viewing Galaxy. Wait a bit, just to make its operations. And here we go to check out the satellite. So here we have the satellite place mark, its name, its status. We have a balloon as well showing its photo. It's some info right here, such as the NORAD ID, its alternate names. And the most important thing, we can see this red line over here that represents its orbit. So let's turn off the balloon, just like the ground station. And we can see better the orbit. So if I move the Liquid Galaxy over here, the Google Earth, we can see that there is a full orbit around the Earth. So let's stop here. Let's hit the orbit button to go back to the satellite and start an orbit tour. So here we are. We may stop the orbit now. We can change its orbit with a red line. We can change its period. So right now it's set up to 3 hours. Let's increase to something around 6. Wait a bit, and here we go with a more extended orbit right here. So we can see all of this is being calculated in real time. Now the coolest thing we have here is the satellite orbit simulation. So let's hit the simulate button right into the bottom of the satellite card. And we can see that it has started a tour all around, following this red line that represents its orbit. So we shall wait here. It's something around 4 minutes to start the orbit. So here we go with the satellites. We may choose to do an orbit as well. So we go back to its original location, and that's it for the satellite. So let's clear the KML right here. So to finish it all, let's just clear our logos from the Google Earth view. Hit the Liquid Galaxy here and clear KML plus logos over here. So just wait a bit, and gone. We have our logos gone. So that's it for my project. I really thank you all for watching. Thank you for my mentors for helping me. Thank you especially to Paul, who's been assisting me for testing the project into the Leda lab. And especially for you, Andreu, that helps me a lot with a project that gives me the opportunity. Thank you all, and that's it. Bye.
Hey there, my name is Syed, and I'm working with Liquid Galaxy during this GSOC 2022 on the RS2 app. That's the Reforestation Assistant Simulator. It's a 175-hour project for GSOC 2022. Reforestation Assistant Simulator is an app that helps on reforestation of degraded areas by drones or manually. This project was mentored by Lot and Karini. Thanks a lot for your guidance, and a special thanks to Andrew for all the help and support. I'm pursuing Bachelor's of Computer Science from the United States, and the entire idea of Reforestation Assistant Simulator is that it consists of an Android app where users can plan reforestation missions. They can define area of seedings. They can plant specific seeds and tree at a location. They can define drone landing points, fly zones, and all other helpful metrics. And all this data is dynamically displayed on the Liquid Galaxy cluster using KMLs with the help of graphics and great visualizations on the Liquid Galaxy system. So thank you once again to the entire Liquid Galaxy team, and let's dive in. This is a preview of how our app is working on the Liquid Galaxy rig. So when the app is launched, it automatically establishes a connection and displays the logo on the extreme left side of the screen. And this happens automatically as soon as you open the app. So the connection has been established. All the buttons are being displayed in the settings. When you click on Clean Logos, it cleans all the logos from the Liquid Galaxy system. Now, going back, we can do a lot more using the RS app on the Liquid Galaxy system now. Apart from just displaying the auto logos, we can just click on Launch to LG, and the app seamlessly launches the KML, the project KML, on the Liquid Galaxy system. This basically displays all the information like trees, their names, and their region, and marks their region inside the Liquid Galaxy system. Now, we can also clean the KML, and by using the Clean KML button, it will clean all the data from the Liquid Galaxy. When we click on Orbit, it starts orbiting on the Liquid Galaxy system. Now, we can also add the graphs that are present in the app. So we have all that information, all the project information, added directly to the Liquid Galaxy system. So when we click Add Graph, it adds all the graphs and all the project information on the extreme right screen of the Liquid Galaxy system. So we can add all those graphs one by one, or we can add selective graphs to the Liquid Galaxy system. So here's a quick preview of how the graphs look. They look awesome on the Liquid Galaxy system. Now, when we click on Stop Orbiting, the Liquid Galaxy stops orbiting. And when we clean the KML, it removes all the KML information, including the logos, the graphs, and all that project information. So now we also have this map that's present inside the app, and we can just view the same information on the app as well that we're seeing on the Liquid Galaxy system in a much more immersive manner. So this is our preview of the Android app, the functionalities we have implemented, the features we have implemented, the bug fixes and everything. So now we're going to launch the RS2 app that's on the Android phone. So we go and launch the app. It starts with a completely new splash screen with new logos and a new design where we have placed some different logos. Now, when the app is launched, we see all the projects that are present in the RS app. And now we'll be first going to the About page. We have a completely redesigned About page where we have the new privacy policy. We have the list of contributors and which period they contributed. We have the names of our esteemed mentors here. It's Lot and Karini for GSOC 2022. We now also have a new section that allows the user to visit the contributors' GitHub and other social pages. Then we have the description, and we also have certain links here where we can go and browse the Liquid Galaxy website, the RS2 project GitHub, or Drone Korea's website. Now, going back to the project, we see all these projects here that are loaded using the predefined database. Now, we can also sort them using new filters, where we can go about sorting them according to the name, the area which they're covering, or whether they're whether we want to see the newest projects or the oldest ones first. So let's go ahead and try out this name. So we have A to Z, and if we want to do that, so we see that it's sorting it starting from Z to A, and first it was A to Z. So these are the new filters for the RS2 app. Now let's go for the oldest projects. Let's do this name. Okay, so now we have our projects sorted and using different filters. Let's go to this project, and we can do a lot more now. All these UI changes where you can see a completely revamped UI where we have all the dates, the sewing mode, the region right up in front, like right exactly next to the dates and right below the project name. We have done away with all the extra information that was repetitive. Now we are starting to get into the project information directly. So we can now calculate the CO2 capture and delay, CO2 capture that's planned, the time taken to cover per hectare, and the number of plants. All this is automatically calculated. So the user doesn't need to input anything. It's automatically calculated using the variables and all the information we're getting. Also, we can download the PDF for the entire project, and we can also save the KML file. So we can download the KMLs and the PDF. We also have a completely new format for the PDF. Let's just go and browse it real quick. So now our PDFs also contain all the essential information along with the graphs for the project, so that if a user is printing out this PDF for some purpose, they also have all the required information that's presented in our very unique graphical visualization. Now, coming up to the sowing window time and the species information, all this information is present right here. We also automatically calculate the seed ball diameters, the number of seed balls and the number of flights using the seed ball diameter. And the user just needs to enter the seed ball diameter in our program, and our app is able to calculate it automatically, like what's the number of seed balls and how many flights would it take to plant all these seed balls. Now come into area information. We now have a separate area that shows all the information about the area, like the area covered. It's 3.48 hectares for this project. This information is also automatically calculated using the maps. So if we go to the Google Maps and try to see, okay, this is the region we were working with. So the app is not capable of automatically calculating this area which the user has defined, rather than asking him to estimate it or manually input it. Now, coming to the drone mission, we also have some attributes where these values are now rounded off to a greater precision. And now we also have a separate area that's drone mission. So we have the total flights, the size of deposit, and this is also automatically calculated. Now coming up to these completely revamped graphs, this is the survival information, where the user can now even customize the percentage of a particular species dying by predation or hydric stress or thermal stress or certain other factors. So if we want to get the estimation for a particular species, let's say common beech trees, so we deselect all of them, and if we try to customize, we see that the data is updated live. So all that is happening live. So if a user wants to see the results of how exactly a particular percentage is impacting their project, they can see it right there. And we also have this axis where we denote, okay, these are the total number of plants, these are the seeds, and all the factors that are playing a role in impacting the actual survival. Now, as we can see, it's customizing everything live. And we can do that for other species as well. Like if you want to combine all the species and define, okay, all the species are having this much of percentage that's dying. So we can customize it for all species as well at the same time, or we can choose a single species as well. Now coming up to the new potential CO2 capture graph, this is a graph that basically shows us that the potential CO2 capture that the project is doing over the years, this is automatically calculated as well. The user doesn't need to input anything. He just needs to select the plants, and we are able to construct a really beautiful graph out of that information. And same here, we can either select all of them. These are the cumulative values for the entire project. So we can see, okay, this is starting at 0 and then going up to around 125-ish. And this is the total impact, the total CO2 capture the project is estimated to do by 2029. And if you deselect, okay, let's just select common beech tree. So the axis and everything is automatically customized. And now we can see, okay, common beech tree is going to do around 40 kgs of CO2 capture till 2029. Now we also have this total CO2 capture per species, which is denoted by this graph. Now coming up to the species, we have completely revamped now we can also input the seed ball diameter in the species using the other tab. Thank you. This is the end of presentation for RIS2. It's been a wonderful time working with Vlad and Karini, who were my mentors for GSOC 2022. Special thanks to Pau for testing and taking all the pain to test my application, getting all the bugs and everything. And a great thank you to Andrea, who was the org admin and was there to support us, guide us in all times. Thank you for the wonderful GSOC.
Hello, I'm Lot Amoros from Dronecoria and one of the mentors of the Reforestation Assistant and Simulator project. This smoke that you see over there is a wildfire near to me, and this project of this app could help to capture the CO2 that are burned go to the atmosphere in the wildfires like that one. Syed make a wonderful job this year in the Google Summer of Code because he implemented different simulators for different simulations of survival of the different species. So it's a wonderful step this year, be able to calculate the tons of CO2 in a reforestation project. Also, we arrived to publish the app in different Play stores. This is amazing because we will be able to share the app with the rest of the world, having the feedback, improve the app also in GitHub. No, so I believe that this is a wonderful step for Dronecoria, for the project, and for people that are working with the reforestations. Thank you, Google Summer of Code, Liquid Galaxy, the rest of the mentors, and Syed. Bye.
Hello, my name is Guillaume Camats. I'm a GitHub contributor, and I'm currently working on the project called CrapDog for Android. Okay, so the project is about developing an application to help farmers to detect certain crop illnesses on the terrain and display the location of the terrain and the trees affected by this crop illness on the Liquid Galaxy to help them monitor the evolution of the illnesses through the territory. This problem will be solved through an Android application that will have a machine learning model integrated on it that will detect the illness of the sample. After that, allocation of the terrain and the location of the sample will be linked to the sample, and finally this sample will be displayed on the Liquid Galaxy. This project is divided in two parts. First, the collecting data. I do this by first analyzing the leaf with a machine learning application, and then storing the terrain, the locations of the terrain, and the location of the sample in a JSON file and saving it to shared preferences. And by doing this, I don't use external APIs and external databases. I use only the memory of the phone. The second part is visualizing the data in the Liquid Galaxy. So I do this by taking the data from the JSON file previously saved and displaying the terrains on the app. From then I can see all the terrains that are saved on the app. Then I can choose any terrain and send it to the Liquid Galaxy to see the terrain and the samples, and each samples it has their condition and the accuracy of the prediction of that prediction. Hello, so now I'm going to show you guys how the application works. Here we have to analyze the photo and save the data. Here to the LG utils. Here are the send KMLs, and here we have the about. I'm going to show you the about. This is the logo of the app, the people that helped me in the application, all the logos, and a brief description of the project. So now I'm going to analyze a new photo. Here, as you can see, we can select any photo of the gallery. For example, we will select this one, and instead we will select another one that we can see more. As you see, I can change the photo that we want, and if I confirm, it says that the prediction says that it's healthy and it has an accuracy of 78%. So if you see, here is the prediction, and we can add the location. We will create a new terrain for you to show, and we press this. We can reset markers. As you saw, we can reset all markers if you want, and we press reset markers and all the markers are deleted. And so now I'm going to create a new terrain, and I'm going to put terrain Lleida number 2, and we will save this terrain, and then we will select it, and we will zoom again to where we are, and now we see the location, and here we put the prediction of the sample, and this will be the position of the tree inside the terrain. And we see that it's healthy and it has an accuracy of 78%. So we save this marker, and now we have the terrain created. Now if we will send the KMLs, and I will connect to the LG. Now we are connected, and I can send a KML. As we see, well, we're gonna delete it first, and now we are going to send the KML. So we select the terrain and send the KML, and we see that the application zooms into the where we were, and we can see the prediction, and we can see the logo and the bubble. And in the bubble we can see the photo of the prediction and a brief description of what the terrain contains. And then now we can see the orbit. As you can see, the orbit works perfectly. If we want, we can stop the orbit. And I didn't click it. Okay, now we stop the orbit. And if we want, we can delete all the KMLs. We click clean KMLs, and everything on the screen is deleted. So this is how my application works. Hope you enjoyed the video. See you. Bye. ¿Es bien las fotos?
Sí, vaya las fotos, vaya el rig, vaya el móvil.
Claro, además Japó. Mira que las fotos son diferentes. Vaya, Nueva Zelanda. Me piro a Estados Unidos. Es veuen les fulles, sí, no? Vale. Faré i ja tens tot. Vale, ja està. The model that I'm using in my application called CropDoc for Android was created with TensorFlow Lite Model Maker. This model is able to recognize certain crop illnesses displayed to the territory through images of foliar diseases of apple trees. The model was created with TensorFlow Lite Model Maker. TensorFlow Lite Model Maker is an application of TensorFlow that helps the user to create light models, and these light models are perfect to use with Android devices or any kind of mobile phone device. For the creation of the model, I'm using a pre-trained model that is called EfficientNet Lite 4. EfficientNet Lite 4 is a pre-trained model that currently is the best on the market. That means that has the better accuracy of all other pre-trained models. And to train my model, I'm using this efficient Light 4, and I'm training it with my own dataset. The dataset that I'm using is a Kaggle dataset that is called Plant Pathology 2021, and it's for finding foliar diseases of apple trees through the images of the leaves. I chose TensorFlow Lite Model Maker to create my model because TensorFlow Lite models can run on any device. That means that if a mobile phone has a low characteristics, my application will work too. And for doing this, I sacrificed a little bit of accuracy of the model, but I think it's worth because everyone can use my application.